Hello everyone, this is Geethanjali. In the last video we did law of independent assortment, and in this video we'll be doing chromosomal theory of inheritance. So Mendel actually published his work somewhere around 1865, but it was not recognized till 1900. So there were many reasons for this. Firstly, the communication was not easy at all at those times. A single message would take so many days to be transmitted, and also his concept of genes, that they were stable and discrete units, was actually not accepted by many contemporaries because in nature there was a lot of continuous variation seen, and also intermediate characters were obtained. So the fact that they did not blend with each other was not accepted. And thirdly, Mendel for the first time used maths, to explain biological phenomena, which was actually unconventional at those times. So that was also not accepted by many biologists. And then finally, Mendel's work suggested that genes were discrete units, as I told you, but a physical proof was not there. It was he only performed experiments, and those experiments had to be verified, but there was no physical proof as such. So that is why point 2 did not help in his recognition of his work. So what happened later in the 1900, De Vries, Correns, and von Chemark independently rediscovered Mendel's results, and they were pretty much surprised to see that all his principles of inheritance were actually true, and they verified them. So later also two other scientists, Walter Sutton and Theodore Boveri, they proposed this theory, chromosomal theory of inheritance. So what they noticed was there was a pattern of similarity between the behavior of the chromosomes and behavior of their genes. So they proposed that there were similarities seen in the behavior, and hence genes are basically present in the chromosome itself. So let us see how they're actually similar. First thing is that when we say chromosomes, we usually refer to homologous chromosomes. So this homologous chromosomes, we know they occur in pairs, and also the genes occur in pairs, and this is one similarity. The homologous chromosomes, they separate at the time of gamete formation, that is during meiosis. They actually pair with each other like this, and later they separate during the gamete formation, that is during the meiosis itself, right? So even the genes that we see, they segregate at the gamete formation, and only one of each pair, that is only one allele, is received, that we saw in law of segregation. And the third point is that the independent pairs segregate independently of each other. So what does this mean? So you can see here there is one pair of homologous chromosome, and there is a second pair of homologous chromosomes. So this one pair segregates independently of this pair. There is no sort of link between these two. This is what the third point means. And here the third point says one pair segregates independently of another pair. So here you see there is a difference in points. So here we saw that independent pairs segregate independently of each other, one pair separates independently of another pair. So here we don't call the pair as independent because there's an exception of linkage. There's something called linkage, which is an exception, and hence we don't call it an independent pair completely like how we call in the case of chromosomes. Okay, so we'll learn about this in the next video. So this was actually the point of similarities that they had actually seen. So what Thomas Hunt Morgan did was that he experimentally verified all this with the help of Drosophila melanogaster. Okay, so he used Drosophila melanogaster to perform experiments and thus prove this theory. So he chose this because of the following reasons. First, that it could grow easily on simple synthetic medium, and its life cycle was pretty much short itself. It was just 2 weeks, and a single mating would produce so many offsprings or progenies. So they could analyze all the offsprings and progenies easily, and also the male and female. So you can see here, this is the male and this is the female. They were easily distinguishable because of their size. And the variations that we usually see, so suppose the eye color or the body color or all those variations we see from like red, white, or all those colors, they could easily be seen with the help of low power microscopes. Not much equipment was required, so that is why they chose Drosophila melanogaster, that is the fruit fly. So these were few points that you had to know about chromosomal theory of inheritance.